Okay, so this worksheet is going to introduce simple uses of amortization schedules and some advanced uses of amortization schedules. We use an online amortization schedule calculator ultimately. But let's have a look at this problem. This will be useful for project 2 in determining some of the payment strategies in that project. So the situation from the beginning is, suppose we're interested in purchasing a house which costs $175,000 and we have $25,000 in savings that we intend to use as a down payment. So $175,000 minus $25,000, our loan principal will be $150,000. In other words, we'll have to borrow $150,000 in order to pay the remaining balance of the house. Then over 30 years, we'll pay that $150,000 back at an interest rate of 3.5% for monthly payments. Okay, so an amortization schedule is a list of every single payment made on this mortgage with a breakdown of how much each payment is paid towards interest. So payment 1 all the way through the very last payment, how much interest is paid in each payment, and then how much principal is paid in each payment. This changes with every payment because as the loan proceeds, the principal goes down and the amount of interest owed is less. So the most interest is paid in the first payment and the least interest is paid in the last payment. Okay, so to get started, Part A asks us to use an online amortization schedule to calculate the regular monthly payment and round or take your answer to the nearest cent. So always follow the instructions for what our answer format is, especially in the WebAssign quizzes. So let's have a look at an amortization schedule online. One of my preferences for an amortization schedule is, you'll see in the address bar, amortization-calc.com. A quick Google search brings this one up. It's pretty good because we can adjust the year to a fine amount, and we'll see that later on in a more advanced question. So if we look at the top, we have a loan principal of $150,000, so that's correct. Our loan term is 30 years, given to us by the problem. Our interest rate is 3.5%. We'll write that as a percentage here. We don't have to adjust it to a decimal because this calculator does it for us. What we see to the left under mortgage summary is we have a monthly payment of $673.57, total of 360 payments. So this is the total cost of the loan, or total paid towards the loan is $242,484. We see total interest paid, $92,484. And perhaps we'd write all these things down on a sheet of paper so we can make the calculations that we're going to have in the rest of the questions to come. So we get our basic information here, and let's answer the questions that follow. So going back to our worksheet, use an online amortization schedule calculator. Okay, done that, to calculate your regular monthly payment. So our regular monthly payment we just saw in that amortization calculator is $673. They ask us to take it to the nearest cent, 57 cents. Well, that was already done for us, but that's fine. Okay, so our payment is this. The total cost of the loan, well, that amortization calculator gave that to us as well. If we wrote that down, we recall that that was $242,000, 484. 0 cents. We'll take it to the nearest cent. If there's no cents, we just put 0.00. Okay, that's the correct way to satisfy these instructions right here, just for answer formatting and our more complicated web campus assignments. Part C, what is the total interest of the loan over the term or life of the loan? The term of the loan is the amount of time that the loan goes on. Well, we also had that, the total interest paid from the amortization calculator. If we wrote that down or go back to it, we'd find it was this amount, $92,484. Again, 0 cents, satisfying the format of the answer. What percentage of the total cost of the loan was paid toward the total interest of the loan? Okay, so we do have to do a few calculations here. So what we're asking for is, in total, the total cost of the loan, which is $242,000 roughly, and what percentage of that was the total interest of the loan, the $92,000. Well, that's fairly straightforward once we see that. percentage of the total cost, that was interest, or we'll say this, percentage interest is given by dividing the interest amount divided by the total cost of the loan. 242,484. And they ask us to round our answer to the nearest hundredth of a percent. Okay, well, we'll do that when we get there. Plugging this into a calculator, we get a number rounded to the nearest percent, which is 38.14%. Okay, using standard rounding rules and converting the decimal that we get from that division to a percentage. Now, percent that's principal, there's an easy answer to this. We could do the same division. Our principal is 150,000. We could divide that by the 242,000 total cost of the loan. Or we can be a little bit more clever. If it's not principal, then it's interest, and vice versa. So if our loan was 38.14% interest total, then the remaining of the 100% is going to be principal. Okay, so we just use the complement rule to say the following. It's 100% of the total cost of the loan minus 38.14%, as we have here. And what this comes out to, and this is approximate because that 38.14 was a rounded value, but this comes out to 61.86%. So the breakdown of our total cost of the loan is that 38.14% of it was interest over the entire life of the loan, and 61.86% of all of our total payments was paid towards principal. And that's of this amount up here. That's the breakdown of that 242,000. So quite a bit of interest is paid in this scenario, but not as bad as it could be. 3.5% APR is pretty good for a mortgage. Okay, part E. What percentage of the first payment goes toward interest and what percentage goes toward principal? Okay, so we need to look at our first payment in our amortization schedule, and this is where this schedule really shines. So we'll go back to that in just a moment, but I'm going to call the first payment payment 1, subscript 1. So that's our first payment, and we know that every payment consists of the amount of principal paid in that payment plus the amount of interest paid in that payment, and that changes with every single payment that we pay on our mortgage. Okay, so let's find what these are. Principal for the first payment, interest for the first payment. So we'll go back to our amortization schedule. Down here, this is where this list starts to help us out. Our first payment is March 20th. It's the top of this list. The interest is $438. The principal in that column we see $236. So let's write both of these things down on the worksheet. So we've got principal was $236 plus the interest is $438. We're being only as precise as that schedule is, so we don't have the cents here right now. We don't need to add these up. We know that these should roughly sum up to $673.57. It looks like it sums up to $674, so they're rounding in this. Again, they're not being very precise, but that's okay. So what percentage goes toward interest and what percentage goes towards principal in this payment? Well, this one's fairly straightforward. We'll take percentage interest, and we'll say that this is the amount of interest. It's $438 divided by our monthly payment is $673.57, and we'll have to round this, but when we get an answer here, this is 65.03%, rounding this percentage to 2 decimal places. We rounded this percentage to the hundredth of a percent, with 0.03 being the hundredth of a percent. Okay, we can use the same trick for the percentage principal as well. So percentage principal, we'll just use 100%, and it's rounded because, or approximate because this number was rounded, 65.03%. Again, that complement rule just helps us have a shortcut. Otherwise, we could divide 236 by 673, get something similar. And this amount comes out to 34.97%. Okay, carrying it to the second decimal place, or the hundredths of a percent. So that's payment one's breakdown. It looks like quite a bit more interest, 65% versus the principal being 34.97%. Okay, what happens in the 240th payment? Okay, so the 240th payment, these are monthly payments, so 240 months later, just make a note of this, 240 months is equal to 20 years. Okay, so we need to look 20 years later down the road in this amortization schedule. So let's go back to our calculator, have a look. So March 2020 is our first payment. Let's see, 12 payments later would be February 2021. Right? March through the following February is exactly 12 months. So 20 years down the road in February will be at our 240th payment, or 240 months later. Okay, so we need to look at the year 2040 and the month February. So February 2040, we scroll down to get to that. February 2040. So we look just about bottom of the top third of the page. We've got February 2040. It looks like our interest is $200. Our principal is $474. Remember, interest is on the left, principal's on the right, and our two columns next to the date. So $200 for interest, $474 for principal. So payment 240 breaks down into, well, it's principal for 240 plus the interest for 240. And again, this is just to write the breakdowns. We don't need to add these numbers. We know they should add close to $673.57, and they do. But our values were $474 for principal in that payment, plus $200. That's what we saw in the amortization schedule. So now we have all the values we need. So the percent that's interest in this payment is equal to $200 divided by 673.57. We can already suspect that that's going to be lower. It's much less interest than we paid in the first payment. And our percentage, in fact, is 29.69%. Using a calculator to get that, converting it back to a percentage, and rounding it to the nearest second decimal. So percentage principal is equal to, same trick, or we could divide 474 divided by 673, either way, but this is just a little easier, and it's close enough for the intents of the project. That's just fine by me. Okay, and let's see, what is our total here? 70.31% in this case. Okay, so we've got our breakdown for our 240th payment. Roughly 30% interest and 70% principal, compared to 65% interest and 34% principal of our first payment. So as you can see, you pay less and less interest as time goes on with one of these loans or mortgages. Okay, so that's just the regular payment strategy. One of the next questions you'll see in Project 2 is, well, I want to pay things down more aggressively. So the prompt here says, suppose things are going well financially as soon as you close on this loan, or close on the sale of this house. In other words, as soon as you buy the house, and right when you start to make your first payments on it, you realize you can pay 25% more on each payment. So you're going to pay the full payment plus 25% more of that payment. That extra payment that you're making is going to go towards the principal, lower the balance of the loan, and overall take you less time to pay the loan back, and also reduce the amount of interest that you pay in total. So first thing to calculate, if we're going to pay this 25% extra, is, well, what dollar amount is that extra 25%? So quick calculation there is to say our payment, monthly payment from the previous page, or the amortization calculator times 1.25. So what's happening there? I'm saying that we're going to take one of our payments plus 0.25 plus 25% of that payment. Right? This is a trick we've used a few times now. Or you can just do the payment plus 0.25 times the payment. Whatever is fine, whatever works for you to increase it by 25% is just fine. So this nice quick trick here is $673.57 times 1.25 okay, and that's equal to, or approximately equal to, we're going to round it to the nearest cent, $841.96. So that's what our new payment's going to be, okay, and that's going to, anything that's added to that $673 right here is applied towards the principal. So we're paying that much more principal each time. It should take us less time to pay this loan back, and in fact it will. And overall we'll pay less interest because we've carried less balance each month as time progresses. So let's have a look. We want to know how long it will take us to pay the loan back if we're going to pay this extra amount. And this is a question from the project, so it's nice to know how to do this. One of the easiest ways to answer this question is this: trial and error with an online amortization schedule calculator. Okay, so we'll go back to that calculator I showed you, and we're going to use some guess and check methods. And the idea would be this: we're going to change our time in the formula until we get a payment that matches or is close to this one. Okay, that $841.96. So let's go have a look at how to do that. Now, scroll back to the top in our calculator. We see that our monthly payment is $673.57 on the left. We need that to be $841.96, or as close as we can get within reason. And the only thing we're going to change is the amount of time. We want to know how long it would take to pay back a loan if we pay $841. So we're working in reverse, saying, okay, maybe we take out the loan for 20 years instead. What happens when we calculate this? $869.94 is our monthly payment. So it's a little closer. So, we're not paying quite that much, so it'll take us a little longer than 20 years. So let's try another amount. Maybe we try, but we're not far off, so we'll try 22 years. Here, calculate that. $815. We're paying a little bit more than that, so it shouldn't take us as long as 22 years. So let's try one more. Right between 20 and 22 is 21. Calculate with 21 years. We get $841.38. That's pretty lucky. That's really close to $841.96. So I think we're close enough to just say it's going to take 21 years to pay off this loan if we pay $841.96 per month, because that's just awfully close to $841.38. So note the rest of these. The total of 252 payments is $212,027, and the total interest is $62,027. Write those down, and we'll use them in the worksheet. So here we are back in the worksheet, and let's see. We've determined using some guess and check, and it might take longer than it just took us. We could even use a decimal amount of years using that amortization calc website I choose to use. But we see that it's going to be about 21 years. It's not exactly, but it's pretty close. We got lucky with this value in this problem. Okay, so about 21 years. Okay, so now let's answer the rest of these questions. What's the total cost of the loan? Well, that was easy to get. It was right there at $212,000 and $212, $27.00. Great. Box that up. We've taken our answer to the nearest cent, so great. How much of the total cost of the loan is interest? We wrote that one down as well. $62,27. Okay. Directly from the amortization calculator, that's great. Not much work to do here. We're taking our answer to the nearest cent, as we've been asked to do. Now, what percentage of the total cost of the loan is the total interest of the loan? Okay, so percentage that is interest in this case, percentage interest is equal to, well, our interest total amount is $62,027, and we'll divide that by $212,027. The .00 doesn't matter for either of these. These are still equal. It's just for answer formatting that we have to do that. And the value we get out of this, converted to a percentage and rounded to the nearest second decimal place, comes out to be 29.25%. Okay, and that would leave, using our quick trick from before, the percentage of principal paid over the entire life of this loan to be 100% minus that 29.25%. And this is equal to 70.75%, okay, over the life of the loan. And this is that total cost breakdown. 29.25% of our total payments goes towards interest by the time the loan is over. Let's compare that to problem 1 as the question suggests. We have to change the page and go back over to the left. Total interest paid in our first scenario is 38.14% versus and 61.86% for principal. Comparing that to these two values, more of our payments go toward principal in the second scenario, of course, because we paid extra principal each month, and less of our payments go to interest. Also, some things to note between these two. The total cost of this situation is $242,000 with $92,000 in interest. And if we go back to our aggressive payment strategy, we've got $212,000, a $30,000 difference with $60,000 in interest. That $30,000 represents that much less interest we pay by paying this little bit extra each month. So $30,000 difference in interest for these two scenarios. Okay, that's essentially what you need for the more complicated parts of Project 2. I hope you have fun with it. I hope you learned some things from it, and good luck.